So let's first do the basics before we jump to the straight lines and circles and other stuff. Okay. So what are the basics we learned in our previous classes till 9th and 10th? We learned that we have quadrants. First, we have these axes. Okay. This is called the rectangular Cartesian plane. Okay. I will write it down here. Rectangular Cartesian plane. Now why is it called a plane? Because it has just two axes. Okay, if it had three axes, it would be called the solid, right? So it would be called a space if it had three axes, x, y and z. But in this case it will have only two axes, which is x axis and the y axis. Okay, and you must be familiar with the two terms which are abscissa and ordinate. If I have this point, okay, and we'll denote this point by x comma y, where x will be the abscissa and y will be the ordinate of that point. Okay, so in this x comma y, x is the abscissa and y is the ordinate, right? It's not coordinate, it's ordinate. Okay, there's no c over here. So see, the thing what happens is, this is a positive x-axis, okay, and this is a positive y-axis. Similarly, this is a negative x-axis, and similarly this is a negative y-axis, right? So the points which will lie over here will have positive x coordinate and positive y coordinate. Okay, so both x and y coordinates will be positive, right? And the points which will lie over here will have positive y coordinate but negative x coordinate, because it lies near the x-axis. Okay, so it will have negative x coordinate and positive y coordinate, right? So in this case both the coordinates will be negative, and in this case they will be positive over here and negative y coordinate. Clear? Okay, so this is the basic we are learning from the past 3 classes. Okay, so we'll jump to the next level. So, what are the other basic things? First, we're going to see that if we have 2 points on this plane, let's say this point is x1 comma y1, okay, and this point is x2 comma y2, and I want to find the distance between these 2 points. How I'm going to find that? So let's see, let's draw a line which is parallel to the y-axis, the x-axis here, and a line parallel to the y-axis over here. Now we want to find this distance. Okay, this is ABC. I want to find the distance AC. So how are we going to find the distance AC? Is by applying the Pythagoras theorem. Very simple. Okay, so what is the distance over here and what is the distance over here? Okay, so if we simply calculate AB and BC, we can simply do AC square will be equal to AB square plus BC square. Okay, simple stuff. Now this point, the abscissa of this B point will also be x2. Okay, so this distance will be equal to x2 minus x1, because this whole distance is x2 and this distance is x1. So this distance is x2 minus x1. Similarly, this is y2 minus y1, right? So AC square will be equal to AB, which is equal to y2 minus y1, okay, square plus x2 minus x1 whole square. So we can say that AC is equal to under root of x2 minus x1 whole square plus y2 minus y1 whole square. So if I have to find the distance between 2 points x1 y1 and x2 y2, we can simply apply this formula, and this formula is called the distance formula. Okay, distance formula to calculate distance between 2 points x1 y1 and x2 y2. So here AC is equal to distance between points x1 y1 and x2 y2. This is pretty simple stuff. This is just the application of the Pythagoras theorem, which we know we've been learning since the past 4 classes. Okay, so everybody is clear with this stuff? Okay, let's move to the next topic. So the next topic, which is very important, okay, this topic, this thing which I'm writing over here, we're going to use all over a coordinate geometry as well as in our calculus. Calculus means differentiation and integration. Okay, so what is slope? Okay, let's suppose this is a curve. Okay, I'm moving slight off topic because we have to understand what is the slope first. Okay, so let's say this is a curve. Okay, I have to find this gradient. Okay, that what angle it is making with the positive x-axis. Okay, so how can I find that? This is actually done by differentiation. Okay, but what you need to learn over here is that this thing is called the slope. Okay, this gradient or this inclination, you can say, this inclination with the positive x-axis is called the slope. So we can say that inclination of the curve with respect to positive x-axis. Okay, so we can say that if we have a straight line, okay, is that slope ever going to change? Now this slope is never going to change. Okay, never throughout its whole journey from here to here. Okay, so what is this slope? This slope here. Okay, this slope m is the denotation of slope. M is given by tan of theta. Okay, so this means it is the tangent of the theta it is making with the positive x-axis. Okay, so if I have 2 points over here, x1 y1, and this point is x2 y2, then the slope will be given by m is equal to y2 minus y1 upon x2 minus x1. This is also the simple application of this triangle. If I am going to make this triangle, this is A, B and C. What is the value of tan theta? Tan theta will be equal to AB upon BC. Okay, now this AB upon BC is nothing but y2 minus y1 upon x2 minus x1. Okay, so if I am given 2 points x1 y1 and x2 y2, I want to calculate the slope of the line formed by these 2 points. Okay, that will be given by m is equal to y2 minus y1 upon x2 minus x1. Pretty much clear? Okay, so what is the slope between the lines formed? Slope of the line formed by these 2 points. Can you find out? So this will easily be given by m is equal to y2 minus y1 upon x2 minus x1. So this is 6 minus 4 upon 5 minus 3.